Welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on LeetCode and we will try to solve it together. So today's challenge is not so difficult one. Okay, so let's try to understand the problem statement at first. Maximum number of distinct elements after operation. So you are given an integer array nums and an integer k. You are allowed to perform the following operation on each element of the array at most once. Okay, so you can add an integer in the range of -k to k to the element. Okay, so and return the maximum possible number of distinct elements in the nums after performing the operation. So definitely first try this problem on your own because it is quite doable, and then only continue watching the video. Okay, so this is the nums array which is given to you, and you are allowed to add -2 to 2 any number within -2 to 2 to any element of the array at most once. Okay, you can add at most once, and you want to tell that how many distinct numbers are possible. So what the nums can be changed to this -1 to 4. So you see, if you subtract this 2 -2 to this 1, you will get -1, and if you subtract this 2 to this 2, you get 0. If you subtract 1 to this 2, you get 1, and you subtract 1 to this 3, you get 2, and 3 and 4 remain as it is. So you can get all the numbers from -1 to 4, which makes a total of 6 numbers. Okay, 6 distinct numbers you get, so that's why your output is 6. Okay, so at first we will try to visualize few of our we will take few numbers and try to visualize that how this operation goes on. Okay, so let's say I take something like 2 2, and let's say I have many 4s in between. Okay, I want to show you that when is the time when I mean things will get duplicated. Okay, there may be a possibility, right? So you see, as in the example, in the next example, there are a lot of 4s over here, and some 4s get duplicated. You by no way you are able to make changes, okay, to this 4. So I will try to formulate a general method by taking examples only. Okay, by taking only examples, I will try to formulate a general method when this thing happens that you are actually not able to remove any number. So let's see, you have this 5, let's say 3 times. Okay, and let's say k equals to 2, so you are allowed to add all the numbers from -2 to 2. Okay, so if you tell that let's say subtract -2 from here, okay, you get 0, and you see all the subsequent numbers has to be greater than 0, because you see duplicate elements aren't allowed, because yeah, it will be allowed, but it would not be counted in the element in the distinct elements, right? So you better not perform it only. So all the numbers which you want should be greater than this 0, and so the immediate number which is greater than 0 is 1. So you can try to subtract -1 from here to get 1. You can try to subtract a -2 from here to get 2, and you can get 3 from this, you can get 4 from this by doing nothing, you can get 5 from this, just add 1, you can get 6 from this. Okay, and you cannot get a 7 from this. Okay, so you have to write it as it is, and you can get a 7 from this. Okay, if you add +2 to this. So +2 is the maximum thing which you can add, but you see now the next number, you have got all the numbers from 0 to 7. Now the next numbers which you want is 8. Okay, so from the remaining 5, you cannot reach an 8 ever. Okay, so you have to copy these 5s as it is. Okay, so maybe not much you have understood, but yeah, you do get when is the time that this 4 and 5 remain as it is, and we cannot, these are the extra values, right? Remaining are the distinct ones, and these are the extra values. So you get 8 numbers over here. So one thing, by doing this, one thing should come to your mind, one point should come to your mind. As I increase k, my degree of freedom should also increase. I mean, what do I mean by degree of freedom? The number of numbers which I can reach. Okay, so here I can reach 8 numbers. So let me increase k to this 3 and use this same example. Now I can use -3 to 3, and I should be able to generate more numbers, right? So let's see, let's take the same example, and we will write something like 2 2, and we will have a lot of 6 4s I will write to have. Okay, so you have 6 4s and you have 5 5 5. Okay, so what is the minimum number which you can get? from this 2 is the minus 3 doing minus 1, and all the subsequent numbers which you will get should be greater than this minus 1. Okay, so definitely you can get a 0 by subtracting minus 2, you can get a 1, you can get a 2, right? You can get a 3, you can get a 1, right? Because 4 minus 3 is what you can do, because minus 3 is allowed to do, and minus 2 minus 1 you can just do it, right? You can keep 4, you can get a 5, you can get a 6. Okay, and you see what you can get is that you can also get 7 if you add 2 to this. You can also get an 8 if you add 3 to this, because 3 adding is allowed right now. And you see you cannot get a 9. What you want next is a 9, so you cannot get a 9. And you see this will remain as it is, so you get one extra number. So instead of three excess numbers, you get one extra excess number right now. Okay, so by doing all these simulations, one thing comes very obvious to your mind is that whatever number array we will be given, we need to first sort that array, because you see sorting actually makes sense, because you get to know which is the minimum number, and all those subsequent numbers will be greater than this minimum number. So I can call this minimum number, let's say mn, and I will try to update this mn as we go. So let's say mn at this point will be 6. Okay, and I will tell that whichever will be the number next, you should give me something more than mn, so you should at least give me mn plus 1. Okay, so this way I can try to do something. So definitely it is an algorithm. Okay, it is a proper algorithm, and I can sort. First of all, I need to sort these nums. Okay, in whichever language you just sort these nums. Okay, and what you do, you keep a base number. So what you do next is that nums, you can do something like nums of 0 minus k, because this is the minimum number which you can get. Okay, so and you try to assign this to minimum. You keep a variable minimum and you try to assign this, and you start your answer from 1, because there will be at least one element in nums. It is already given in the question, and that distinct element is 1. So every number which you will make subsequently should be greater than this minimum, and this minimum mn will get updated every time. Okay, so that's what will actually happen. And you see I try to, for your just comfortableness, okay, I will also as I will explain the code, I want to explain something from this also. So I want to take this example. Instead of 2, what if there was 3? Okay, and I'm just calculating this. You just quickly tell me that what if there was 3? Things would, k is still 3, right? Things would have started from here. So you can get a 0 here, you can get a 1 here, you can get a 2 here by subtracting 2. Note it, you are subtracting 3 here, but you are subtracting 2. So when I will write the algorithm, I will take a use of this. So 3, 4, you can get a 5, you can get a 6, you can get a 7, you can also get an 8, and 2, 5 will remain as it is. Okay, so 0 to 8 is what you can get, and 9 numbers are the unique numbers you can get. Okay, so I hope it is clear to you. So what I will do is very simple. Okay, is I will try to sort the number, find the minimum number, and go keep incrementing the number, keep incrementing minimum also, to see what is the number which I can update to. Okay, so let's say I will first sort this number nums dot begin, and I will also get something like nums dot end, and what else I will get, you have a k with you, and minus k to k is what you can add, right? So you get a minimum number which looks something like this, nums of 0 minus k. You see at least one element will be there in the number, because nums dot length starts with 1. It is already told in the question, it starts with 1. So you will get a minimum number. You can start with an answer which is 1. Okay, and what you can do, you can, while iterating, you can start from I equal to 1 to I equals to nums dot size. Okay, you can just do that. So yeah, you have it, and you want to calculate something, right? Now for each element, you see, for each element it can go anywhere from the lower limit to the upper limit. So what do I want to say by this? I have a lower limit which is nothing but nums of I minus k, and I also have an upper limit which is nothing but nums of I plus k. Now my number should be within this inclusive range of this lower to upper, okay. It cannot go beyond this, okay. So there can be some cases now, okay. So you see, let's say talk of this number 4, okay. The lower, what is the lower of this? This is nothing but 1, right? Because you can subtract minus 3, which is 4 minus k. You subtract, you get 1. So the lower for this is 1, okay. The lower for this is 1. So what can be the possibility? It is possible that this is the minimum right now, okay. This is the minimum. This lower is actually greater than minimum. And let's say if these were some numbers which is less than 2, right? Let's say this was 1 and 1. What would you have got? We would have got minus 2 and minus 1, okay. But you could not have got 0 in that case, and minimum is now minus 1. It is not possible. It is no problem that you get any number which is greater than minimum. No problem actually that if you get any number which is greater than minimum, okay. There would be no problem with that. And you can actually do this if lower is greater than minimum. What you can do, you can increase your answer, and you can assign your new minimum to be the lower, right? Because the lower is 1, which is now the new minimum. No matter, earlier the minimum here was 0, minimum here could have been minus 1, it could have been 0. In both of these cases, I will update my minimum to this 1, which is nothing but lower. Okay, so this is a condition which definitely happens, okay. So I can write something like if lower is less than the minimum, okay, then I can do answer plus plus, and also what I can do is assign the new minimum, which is nothing but the lower, okay. Else if you see, what can be the other criteria? When is the criteria? When it starts to repeat, okay. So when it starts to repeat, you see, you are adding plus 1 to the minimum is now 8, okay. You want, what do you want? You want minimum plus 1, okay. You want 9, but you cannot reach this 9 even after the upper limit. So what is the upper limit of 5? It is 5 plus 3 maximum, which is 8. Even the upper limit of 5 cannot cross this minimum plus 1. So then only it starts to duplicate, but if it was less, we could have done minimum plus plus only, okay. So what I'm trying to say exactly is that what if my upper number, okay, is actually greater than so what was happening here actually was that my upper number was actually less than minimum plus 1, okay. So what was minimum plus 1? It is 9, and it was actually less than 9, right, my upper number. And in that case it was getting violated because yeah, I hope you do understand why, right? It was getting violated, but we could not have incremented my answer in this case because it is the same number. But what if it was something of the opposite kind, okay. What if my upper was actually greater than or equals to minimum plus 1? It means that I could have actually added answer plus plus and do an mn equal to mn plus 1, because you see mn would just increment by 1. You want the next number of mn, you get it, you are telling it in this way, okay, because the upper is greater than or equals to mn plus 1. So I hope that makes sense, and if you just simply return answer, you will get it, okay. This was a pretty simple problem, I would say. If you try to submit it, okay, you do get a wrong answer. Let us try to visualize why exactly am I getting a wrong answer. So you see, I actually did a mistake here, I guess. Lower should be greater than mn, right? Because you see the lower value is 1, so it should be greater than mn. Mn is 0, right? So yeah, I just missed that out. I hope you would have noticed in the video only that Mn is -1 in one case and it was 0 in the other case, and lower, what I was telling, was 1. So lower should be greater than Mn, then only you can add, right? So I hope you would have noticed this, that it was my fault here. So let's see, you got an accepted over here, and if you try to submit this, yeah, we do get a really great runtime complexity as well as memory is also okay. So I hope the method was at least clear to you, and if you have any doubt, definitely ask me in the comment section. Can we do this code a little bit shorter? Do you think we are using a lot of if else or something like that? Okay, so one thing is that there are, you can think this in a bit different way also. There can be two choices of your incrementing the number. One is that from minimum you need to go to minimum plus 1, and that is allowed. Okay, that is allowed. And so let's say in the number line, here is the minimum, okay, and here is the lower. Or there could have been a possibility, you have also would have seen that this upper is there, and you also have minimum, okay, which is minimum plus 1, which is actually greater than upper. So what you could have also done is that, let me think, I am just thinking of a new kind of method. What if I would have taken something like max of minimum plus 1 lower, okay, and this should be actually less than or equals to upper. Do you guys understand what I'm trying to do here? I'm trying to formulate something new, because just something right now clicked in my mind that what if I do something like this? Let me check if it works or not. Even if it does not work, no problem. At least we tried something new. What if I do something like max of mn plus 1 and lower, max of mn plus 1 and lower, and if it is, let's say, less than or equals to upper, we want these to be less than or equals to upper to actually not exceed my upper limit, okay. And in that case I could have updated my answer always, and I could have updated my minimum to something like this. Will this work? And if I just try to run it, do you think, guys, this will work? I have a lot of doubt. Let's see. Yeah, actually this is working. So you see, if you try to submit this, hey, we now have a better memory as well as runtime got increased a little bit, right? So yeah, you could have reduced this, and I hope you did understand this. I am trying to focus only on the upper limit and trying to tell that whichever is the maximum one, so you try to draw it on the number line and see minimum plus 1 is what we want, or the lower is what we want. Among this, whichever is the maximum, that should be less than upper, and that is the sufficient criteria actually, okay. This is the sufficient criteria, and we can do an answer plus plus, or do mn equal to mn plus 1 or lower. So in two of the if statement, I was doing mn equals to lower and mn equals to mn plus 1. I just combined both of the if statement by this max, okay, and nothing else. So yeah, that's all I guess. That was all for this video. I hope you did understand. Yeah, if you have any doubt, you can definitely ask me in the comment section. That's all for this video. I will meet you in the next video. Till then, thanks a lot.